Namaskar, my dear friends. So we have been talking about intelligent power module design and techniques. We have taken an example from DIPIPM, which is SLIMDIP-S package. So SLIMDIP-S package is having capacity up to 5 ampere. It has other package as well, which is having like L, M or other thing, which can go up to 30 ampere ratings. In this session, we'll try to understand what is a block diagram and how it is going to explain us its capabilities and what are the functionalities that it can do for us. So let's open the block diagram of this DIPIPM of SlimDip package. So as we can see earlier, there was a need of like lot of passive components like diodes, resistors, capacitors. We needed high voltage like gate drivers or something like that. We needed separate IGBTs and freewheeling diodes, that is nothing but like flywheel diodes and all. So those were all have been packaged into a single package that is called IPM, which is intelligent power module. Okay. So as we can see, we have in this particular block diagram, we can see we have high side gate driver. So this is called high side gate driver. So as you can see, each of the terminal of high side of gate driver is going to drive the gate of like high side IGBTs. This is my gate 1, this is my gate 2, and this is my gate 3 of high side IGBTs. Other thing is we have bootstrap diode with current limiting resistors connected inside, so there will not be a problem of overcurrent problem. This gate drivers are saved from that overcurrent short circuits or something like that. Okay. Coming back to this particular IGBT, so IGBTs are connected here with my DC link capacitor. So DC link, DC input, and this is having inbuilt freewheeling diode as well. Okay. So this freewheeling diode will be able to manage this particular current during the off switch. If you talk about the rest half of the block diagram, this is first half of the block diagram. The rest half of block diagram, if you see, we have a low side gate driver. This is low side gate driver, and this is low side IGBTs, which is connected to my NU, NV, NW, which is the negative terminal of power supply, which are generally connected to the shunt resistors. And these are other pins also, which we are having low side control signals like UN, VN, WN, and we have low side control supply. And this has fault output pin, and this is having like comparator input pin, which compares the uh, like what is the current amount that is coming into the shunt resistor, that can be compared, and it can shut down the system or shut down the IPM. It has over temperature protection, and also like over temperature sensing as well. It has inbuilt NTCs. So coming back to the explanation of each of these two, like high side and low side blocks, if you talk about here, we can see P side IGBTs. P side IGBTs is nothing but the higher side IGBTs. So it has drive circuit, it has high voltage level circuit shift, okay, and then it has control supply under voltage lockout, as well as it is having without fault signal output, like it is not having any fault signal output on P side IGBTs. It has built-in bootstrap diode with current limiting resistor. So just now we have seen already that it is having bootstrap diode with current limiting resistors. Coming back to the N side of IGBTs, so it has driver circuit and it has short circuit protection as well by inserting external shunt resistor into the main current supply. Okay, so that's where we put shunt resistor. Coming back to this control power supply, this control power supply, actually it has under voltage lockout with fault output signal as well. Just now we saw in the diagram, you can observe here we have fault output signal also. Next is we have over temperature monitoring, like over temperature protection by monitoring LVIC temperature, and as well as we have outputting LVIC temperature by analog signal, which is going to come upon VOTP. Okay, so this will be coming as a analog voltage, which can go through some ADC of my microcontroller, and which can tell us what is the temperature of the LVIC or IC. Coming back to other parts which is having fault output signal, so this is corresponding to N side of IGBT short circuit, and it is going to give us like fault output based on short circuit and n side under voltage lockout as well as over voltage protection. So if any of these three cases occurs, the fault output signal will be active. We have IGBT drive supply, which will be supplying, like a single 15-volt power supply in case of using bootstrap method. So basically the high side voltage supply and low side gate driver voltage supply will be there with 15 volt. We have control input interface, so schematic triggered with 3 volt and 5 volt input compatible and high logic, high active logic, right? So basically we have the control signal with 3.3 volt logic as well as 5 volt logic both. And the best thing it is this particular IC is UL recognized with UL 1557. If we talk about the product lineup of this particular series of DIPIPM, we have SLIMDIP-IPM in S, M, L, W, and X series, and it has like proper motor rating. As you can see, we have 400 watts and 400 watts up to it is 1500 1500 watts or 1.5 kilowatts, and this is going up to 2.2 kilowatts, that is 2200 kilowatts. So it was all about the block diagram of this particular IC that we were seeing it. And if you do have any questions regarding how intelligent power modules are important compared to the discrete solution and why people are actually moving towards the IPM based designs for any of the application, if you talk about air conditioner or cloth washer or like dishwashers, or we have refrigerators, we have fan, and we have pumps, water pumps and all. So everywhere inverters will be needed, and at that place we will be needing a gate driver to drive our IGBTs, and those all are combined into an IPM. This is what the main idea about this IPM module is. Okay. So alright guys, if you do have any questions or any queries regarding the IPM understanding and the block diagram understanding and how to interface our IPM circuitry with our microcontroller, and what are the things that we need to take care while designing IPM circuits, whether what voltage we are giving, or how we are going to design our shunt resistors, and how we are going to design our uh, like over voltage temperature or protection circuits and all. We will be discussing one by one each and every terms in different sections of our training, and we'll try to understand the complete understanding of IPM design. Thank you so much.